Hello class. Today we're going to be doing skill 21. This is radical arithmetic. So we're going to be doing division, multiplication, and addition and subtraction as well. So for division, it says apply the radical to the numerator and denominator and simplify as much as possible. Remember to rationalize. So for all of these, we have underneath our radical, we have uh, a ratio. So the first thing we want to do, instead of writing this as a ratio underneath the radical, we want to write a radical for the numerator and a radical for the denominator separately. So I'm going to go ahead and do that. So that will look like this, similar to if you are squaring a fraction, you square the numerator and the denominator. Here we're square rooting, so we square root the numerator and the denominator. So the next thing we want to do is we want to actually apply the radicals here. For the numerator, I think our best way to apply the radical is to write this in rational form. So I'm going to go ahead and do that. So again, to write this in rational form, this index of 2, we just assume it's index of 2 because there's no number here. That goes to the denominator of our exponent. The reason I wanted to write this in rational form is because I know once I write this as a ratio 8 over 2, I can simplify this to just y to the fourth. Okay, so that will be the next step. But before we do that, let's go ahead and think of how we can apply the radical for x to the seventh. I think the best way to do this is to go ahead and expand x to the seventh. I think that's the best way to visualize how to square root to that. So I'm going to go ahead and expand x multiplied by itself 7 times. So that will look like this. The reason I'm doing this is because I want to square root this. And I know if I wrote it in rational form like I did up here, 7 over 2 doesn't simplify. So I want to go ahead and do it this way and see how I can square root this. So again, we want to pull out pairs of x's. So we have a pair here, here, and here. So we have 3 pairs we can pull out. So the next thing we need to do is go ahead and simplify this ratio. So I went ahead and simplified it down here. Again, y to the power of 8 over 2 simplifies to 4. And then underneath this radical, I was able to pull out 3 x's, and I'm left with just this one left over underneath the radical. And the last thing it says in the instructions is to rationalize. So to rationalize, we need to get rid of this radical in the bottom. So to do that, I need to multiply this whole fraction by the square root of x over the square root of x. So I'm going to go ahead and do that now. So once I multiply the top and the bottom by the square root of x, then square root of x times the square root of x just becomes another x. So we have x to the third times another x, so x to the fourth, and then we end up with the square root of x in the numerator as well. So that is the first example. Let's go ahead and take a look at the next example. So for the next example, we want to do the same thing. The only difference here is we have a cube root this time. So we want to apply that to the numerator and the denominator. Neither the numerator or the denominator can be simplified in this case. So now we just need to rationalize. To get rid of this cube root in the denominator, we need to multiply not by 1 more cube root 9x, but 2 more cube root 9x's. So because we have a cube root this time, we need to multiply 3 of these together in order to get rid of the radical and the denominator. So if I do multiply by 2 more on the bottom, I need to multiply by 2 on the top. So when you are multiplying these radicals, and we're going to talk more about this down here, we want to multiply, as long as they have the same index, we can multiply everything underneath the radical together. So we could take 2 times 9x times 9x in the numerator, which will give you 162x squared. That's 2 times 9 is 162, and then this x times x x squared, and that's still underneath this cube root radical. And then this cube root 9x times cube root 9x times cube root 9x will just give you a 9x without any radical in the denominator. And there's nothing else we can do to simplify this. This is our final answer for part B. Okay. Now let's look at part C. So the first thing we need to do here is apply the cube root to the numerator and the denominator. So I'm going to go ahead and do that. The cube root of 8 is 2. 2 times 2 times 2 is 8. There is no cube root of 25, so we'll need to rationalize that. So I'm going to go ahead and simplify the numerator in the next step, and then we will rationalize. So in order to get rid of the cube root 25 and the denominator here, we need to multiply by another cube root 25 and another cube root 25. We need 3 of these multiplied together in order to get rid of the cube root radical. So if I multiply by 2 more on the bottom, I need to multiply by 2 more on the top. Didn't quite leave myself enough room to do that, but we can go ahead and simplify these now. We need to take 2 times cube root 25 times cube root 25. So the 2 is going to stay out in front, and we just multiply these two 25s underneath the radical here, since they have the same index. So this cube root 25 times cube root 25 is actually cube root 625. And then on the bottom here, since we have 3 of these cube roots multiplied by each other, we're just left with 25 in the denominator. And this is our final answer. Nothing else we can do to simplify this. So the next thing I want you to do is to get the u-tries out and try u-try number 1. So u-try number 1 looks like this. I want you to go ahead and try simplifying this, try evaluating it. First, we need to apply the square root to the top and the bottom, and then go ahead and try to rationalize it, get this answer as simplified as you can. Pause the video and try this now. All right, this is what I got for my answer for number 1. First, I applied the radical to the top and the bottom here. For the numerator, I found it more beneficial to write it in rational form, so then we can see that 6 over 2 reduces to 3. For the denominator, I went ahead and split it up into b to the 10th power times b to the 1 power, because I could take the square root of b to the 10th power easily. That's b to the 5th. And then that just leaves the b underneath the radical. It's another way to do something like this. If it's too long, you don't want to write out 11 b's multiplied by each other. And then we just have to rationalize, get rid of this square root b in the denominator. And that's supposed to be a b to the 6th in the denominator, right? Well, b to the 5th times b to the 1st, and then a to the 3rd times square root b. So let's go ahead and move back to the notes. Next, we touched on this a little bit in those examples, but we're going to talk more in depth on multiplication with radicals. It says multiply the coefficients together and multiply the radicands together. The radicands are what is underneath the radical, and you can only multiply radicands together if they have the same index. So for this first example, we have an index of 3 and an index of 3, so we can multiply these radicands together. So I'm going to go ahead and do this first step where I'm multiplying the coefficients together and multiplying the radicands together, and then we'll have some simplification to do after that, okay? So 5 times 3a is 15a, and then we have our cube roots, and 100a squared times 10a is 1000a cubed. So we can simplify this a little bit. We have a cube root, and we can figure out the cube root of 1000. We can also figure out the cube root of a cubed. So the cube root of 1000 is 10, and the cube root of a cubed is just a. So I'm going to go ahead and write that simplification out. So once you cube root this, you should just get 10a, and 15a is now being multiplied by this 10a, so we can go ahead and multiply these things together, and you should get 150a squared. Nothing left to do there. All right, so let's go ahead and take a look at B. A lot more going on in B, but we just need to multiply the coefficients together first, and then radicands together. These are both underneath the 4th root, so we can multiply these radicands together. I'm going to go ahead and do that now. So this is what I got. 2 times 3 is 6. X squared times x cubed is x to the 5th. Y times y to the 4th is y to the 5th. Then we have the 4th root. 8 times 2 is 16. X to the 3rd times x to the 5th is x to the 8th. Y squared times y squared is y to the 4th. Now we can simplify this radical. The 4th root of 16 is 2. 2 times 2 times 2 times 2 is 16. And then x to the 8th. If we think about this 4 in the denominator here, that would simplify to just x squared. And then y to the 4th root of that is just y. So I'm going to go ahead and simplify that now. So now that I've done that, now we just have these things multiplied by each other. 6 times 2 is going to give me 12. X to the 5th times x squared is going to give me x to the 7th. And then y to the 5th times y to the 1st is going to give me y to the 6th. Nothing else we can do to simplify that. So now it is time to try number 2. So there's try number 2, another multiplication problem. First multiply the coefficients, then multiply your radicands and see what you can simplify underneath this square root in this case. So go ahead and pause the video and try number 2 now. All right, this is what I got. 3 times 4 is 12, and the x just comes over. 2 times 14 is 28. X to the 3rd times x is x to the 4th. Now we can simplify this 28 underneath the radical, because if you do the prime factorization, it's 2 times 2 times 7. So we can pull out a 2, and x to the 4th, if you think about this 2 going in the denominator here, 4 divided by 2, x simplifies to x squared. We're just left with this 7 underneath the radical here. And then we can multiply this 12x times 2x squared, and we get 24x to the 3rd times square root of 7. So let's go back to the notes for this last part. We have addition and subtraction with radicals. So for this, we need to put radicals in simplest form and then combine like terms. Now, when we say combine like terms, that means we can only add or subtract them together if they have the same index and the same radicand. So first we're going to do part A. I'm going to go ahead and simplify these radicals right now. So for 45, we can pull out a 3. There's a 9 in there that we can square root, and 3, we're left with 5. For 80, we pull out a 4. There's a 16 in there that we can square root and get 4. And for 20, you can pull out a 2. There's a 4 in there that we can square root and get 2. So then I multiply these numbers together. I have 9 root 5 minus 20 root 5 plus 8 root 5. So these all have like terms. These all are square rooted, and they'll all have a radicand of 5, so I'm going to combine them now. So 9 minus 20 plus 8 is a negative 3, and we just have the root 5 there. So let's go ahead and take a look at B now. First, I want to simplify the radicals. I'm going to go ahead and do that now. So the cube root of 125 is 5, and the cube root of a to the 4th power is a with an a left underneath the radical here. The cube root of 8 is 2, and this a stays underneath the radical there. So then when we multiply these together, we get 10a cube root of a minus 10 cube root of a. Now these, even though they have the same index and radicand, are not actually like terms because of this a. You could, if you want, factor out this 10 cube root of a from both of these, and then you'd be left with a minus, and then this would just be 1. But let's go ahead and quickly look at this last try. I'm going to go ahead and pause the video, try this one on your own, simplify the radicals, and combine like terms. All right, this is what I got. I was able to simplify these first two terms into 6x root 3 plus 5x root 3. This root 6 does not simplify at all, so we can not combine that like term in the end. There you go.